Welcome to a new episode of Science in Context. I'm Sabine, and this week Dr. Shazia Ruybal Pesántez joins me to speak about genetic epidemiology of malaria. Shazia, what is genetic epidemiology?
In the context of infectious diseases, genetic epidemiology is a branch of epidemiology that aims to derive important information about the transmission of a disease from pathogen genetic data. The pathogen genetic information that we obtain can be used to define strains, genetic lineages and variants, group-related cases of diseases, and provide information about sources of cases or outbreaks and disease spread. For many, the COVID-19 pandemic gave us a real-time picture of what surveillance using pathogen genomic epidemiology looks like.
A recent review you published focused on malaria. Can you explain a bit more?
The potential for genetic epidemiology as a surveillance tool for malaria has been increasingly recognized. However, it is a more complex problem in malaria than for other pathogens, and it is still not fully operationalized for programmatic decision-making in malaria surveillance frameworks. One of the main reasons is a lack of well-defined guidance on how to do this. My work has focused on developing both sequencing and new mathematical and computational methods that help us make sense of malaria parasite genetic data. Likewise, there is now an accumulation of different sequencing methods and analytical tools devised from various research groups that are available to support malaria genetic surveillance. But we now face a somewhat dizzying landscape with many malaria genetic epi-tools available. Their use depends on many factors, including the specific research or surveillance question, access to skills and equipment, and funding available. The nuances of these panels and their pros and cons are not well defined. Along with my collaborators in Australia, we recognized a pressing need to provide this kind of guidance.
This is a really valuable resource. How can it be used going forward?
This review paper can be used as a guide for end users, such as local researchers or program officers, that need to make important decisions about which genetic marker panel is better suited for their particular surveillance application, while taking into account local considerations.
Thank you so much for your time today.
Thank you.